Today we are looking at centripetal force. This is one of the more unusual forces that we see in physics, and it's almost always dealt with or comes up in relation to circular motion. So the first thing we need to do is understand what takes place during circular motion to cause the actual motion to occur. So the first place we could consider this is in relation to a satellite going around the planet Earth. So if we draw our planet Earth there and we have our satellite, the satellite is moving at a velocity which, if we were drawing a force arrow, would take it in a straight direction. But then, to stop it flying off into space, we have gravity that pulls it straight towards the Earth. The resultant force of these two takes the satellite in a slightly less than straight off direction. It goes towards the Earth. If we keep doing this and keep drawing our satellite, and each time we have this arrow that's just going a little bit off center, what we end up with is a series of joined up arrows that, if we made them completely tiny, would make up the orbit that you see the satellite going on. So we have two components to our circular motion. We have gravity and velocity as the forces involved. Now, we need to consider velocity and its parts and its definition. So velocity is a speed in a direction. And if we have a change in velocity, we have what we call acceleration. Now, initially, when we look at our satellite, we would say that it has the same speed, so how can it possibly have an acceleration? Well, we must remember that velocity is made up of two key parts. It is speed in a direction. And in the case of our satellite, the speed is constant, but the direction is changing. If we have a change in direction, our velocity is actually changing, which means we have acceleration. That acceleration can only be caused by a force. Any change in our movement must be caused by a force. This force, in this case, is causing our object to move towards the center, so we call it the centripetal force. And in the case of our satellite, that force is gravity. So, in our current situation of a satellite going around the planet, we have a centripetal force acting, and the name of that centripetal force in this case is gravity. Now, that is not the only force that can act as a centripetal force. We have another two, so in total we have three common centripetal forces. We have gravity, which is the most often quoted in exams. Then we also have friction, and we have tension. To give an example in each case, firstly, gravity, we've already looked at that with satellites. If we want to look at friction, we can consider the bend on a road and a car going round that bend. As the car goes round the bend, its force and its direction of movement wants it to go straight on. However, the car, because of its grip on the road, manages to turn around that road. That grip is a result of friction. So that friction is enabling the car to turn the corner, which means that it is friction in this case, which is the centripetal force. If we consider tension, we could consider a merry-go-round with children playing on it. And when the children play on the merry-go-round, they may well decide to hold on to the bar at the centre. As they hold on to the bar at the centre, they feel a force of tension as they move around. That tension in their arms is, in this case, the centripetal force. So we have there three different examples of centripetal force in action. So in summary, centripetal force is a force that acts towards the centre during circular motion. It acts because although the velocity might be constant, there is, within velocity, a change in direction, which means a change that leads to acceleration. The acceleration needs a force to act, and the three most common forces that we see acting as a centripetal force are gravity, friction, and tension.